I'm going to stick with Alex's approach of asking how, why, and what in opposite order. And what is a very simple question in this case, because we're talking about SCL, and I think you all have some contact with it. And Alex already had some nice foundations about communication and language. And SCL is nothing more than a formal language that is designed for electrical substations. And more specifically, it's to allow exchange of data, and not just between the engineers, but more importantly, we're talking about exchange between engineering tools. And well, engineering tools exchange data all the time. A problem is what happens when you have engineering tools of different manufacturers that may or may not want to cooperate nicely or have changes internally, and then the other tools have to catch up. So SCL for us is very important to get different tools to work together. And just as a quick summary, when we talk about 61850 tools, we have ICTs and SCTs as the two main players. And the ICTs, they are also often referred to as the vendor tools, are, well, usually supplied by the manufacturer with an IED, and they are used to configure the IED, and in many cases they also allow building complete systems. And most of the time, complete systems means systems with devices from the same vendor. The system configuration tools, which can be further split into specification tools and integration tools, are referred to as the SCTs in this talk. SCL can be used as the output and input of each and every of those tools, in theory and by now also in practice. But when we want to look at what happens in the SCL files, it's closely interwoven with the engineering process. When we come to a customer who starts with IEC 61850, this is something that we very frequently encounter. It's called the classical engineering process. Depending on how many different hardware manufacturers are in use, you will have a multiple of IED configuration tools. And then the IEDs get configured with communication data and further data. And at some point, some files are exchanged between the different tools. So, what are those files? I purposely left them with a question mark. And to get to the why of this talk is pretty much this slide. These are all file types that contain SCL. And show of hands, who can name all the content and all the uses of each of these? Some must have this. Okay, so a couple. But this pretty much covers the why am I doing this talk, because well, there is some kind of confusion. All right. Oh, it's still the top left one. Ah, it's got magic. So, before we talk about the specific file types, we'll have a look at general SCL files. And in each and every one, there are 4 major sections to be found. Sometimes sections are left out. The left one used to contain only substation structural information, but by now it can also contain more general systems. So we have generic process, we have lines, we have distributed energy resources, but all in all, they have a common structural section that is mirrored to that of the substation. In here, I'm just showing the part for the substation. We have a hierarchical structure that many of you will recognize, and which is a functional decomposition of the substation. And in here, we'll have the physical fields, and within bays, we find functions and logical nodes as data containers or sub-functions of this. In the IED section, we will find IEDs with a very similar layout. We have a grouping of functions in this case named a logical device. And they also contain logical nodes. And within the logical nodes, we have, for the tools in question, most important part, the configuration of the communication between the devices. And these logical nodes, they find their partners in the structural view of the substation. So this link is not necessarily present during all times. So when you start to design your substation, you may not have included the IEDs yet. You will have logical nodes of types that have nothing to do with any real device. But at some point, we will establish a link between these two sections. And hopefully, when you are done with the engineering process, all of these will have found their respective partners. These logical node types, they're found in the data type section. So here, every single logical node, whether unmapped in the substation section or whether present in the configuration of a device, will have a reference that needs to be defined in the data type section. So if you don't have a reference for the logical node in the data type section, pretty much every tool that exists will complain a lot. And the contents of these type definitions contain other type definitions. You have the data objects, and those contain data attributes. And you may also use enumerations. And all of these need to be present in the data type section. And this is a universal rule that is present for all file types. And finally, we have the network, where we also find a reference from the subnet. There will be access points for each IED in the system that is actually connected to that subnet. And this access point will point to the IED section and find the detailed contents in there. This is the not quite classical engineering process. And here are scattered all the different file types. Now, Alex already said, who can name what this file is about? And there is a small green dashed line over here to indicate that this is slightly set apart from the regular engineering process. We'll look at this file in detail right now. You can see it's coming from a system specification tool, and it's connected to the IED vendors. So not specifically to a software, but rather to a vendor. And that is because the ISD is called a IED Specification Description. So it's not a real IED, rather it's an enumeration of the capabilities that you want to use in your substation, but you do not have a device chosen that offers these capabilities. So it's a specification of what should a device look like that we can use for this project. It's intended to, for example, to negotiate frame agreements or to allow the acquisitions part of the company to have a very clear method of evaluating competing offers. So in this, the most important part is obviously the IED. After all, without an IED, you don't have anything to specify. The substation structure part is slightly grayed out. That's because it's not necessarily a full substation. It may just contain fragments that are in use with the IED. So it's allowed to put some structural information in there, but this is more of a guideline. So just because your ISD file contains substation structure doesn't mean it's invalid. And of course, the data types need to be always present and always match up all the data with all the data that is used in the IED. The network, on the other hand, is pretty much irrelevant. There shouldn't be anything in there or anything of importance. As part of the regular engineering process, the first file that is encountered is a SSD file. It's mediating between the specification tool and the integration tool. And in practice, that's not necessarily the first file that happens, but this is the idealized process. So if you do all your design and all your specification before you even touch a single IED, then indeed the SSD will be the first thing you encounter. So you can see from here, there is not any network information yet. The IED section is grayed out mostly, so you can place virtual IEDs there, but well, they differ from the real IEDs in the sense that there's not a manufacturer associated. I usually don't have a proper name or role, but rather they are placeholders of how many relays are you going to use in your substation and where are you going to put them to use. So the meat of this file is in the substation section, and of course all the data types that are in use need to be filled in. The virtual IEDs may also contain some small part of communication configuration already, not in the sense that is a real data exchange, but rather to document the requirements of the IEDs that will later be used to implement the substation. So when you have an SSD file and you hand it over to the system integrator team or to an external system integrator, the next thing they will need is an ICD file or multiple ICD files. And these get produced by the IED configuration tools and are consumed by the integration tool. So these have some more requirements. Most importantly, they must contain only exactly one IED. And more specifically, that IED name must be template. So if you get handed some ICD files and your tool does not recognize them, it may be worth to look inside and see if they actually are ICD files. So sometimes you get files that claim they are ICD, but may have multiple IEDs in there, or they don't have any that are named template. And in that case, well, your tool can't really make an informed decision what you want to do with this file. It's not getting what it's expected. You probably all worked with ICD files. They're very common in use, but just to summarize, these describe what the relay is capable of from a systems point of view. It doesn't mean that this is all the relay is capable of. You may have a very powerful device or a configurable device where only some of the functions are able to be used concurrently, and an ICD file then exposes one or the other function, or perhaps enforces some other restriction. So the system configuration tool can use these ICD files to create instances of the IED data model in the project. And then these instances can be modified, configured, and finally be part of the substation configuration. So there is a possibility to add some part of substation structure, for example, to illustrate the use of this ICD in a given bay. It's neither mandatory, nor will most tools make use of this. So they will import mostly the IED section and, of course, as always, all the data types that are relevant. And the network section at most contains basically a stub, a dummy network, where you can predefine communication parameters that are necessary or useful for the final configuration. So after a system integrator has received the specification and loaded all the ICDs, a lot of work is to be done, which hopefully culminates in an SCD file, which is the complete system substation configuration description. This is the ultimate result of the engineering process, contains all the IEDs. It usually contains all the structural information, although I've seen projects where just the IEDs were exported. Of course, all the data types are present, and here is the first file where we have a complete description of the network available. And in the ideal case, this will be handed off to actually build the substation. Now, it looks like we're mostly done, and there are still 3 file types left. So let's have a quick look at the IID because sometimes it's not possible to get it right on the first try. So we're looking at a short part of the engineering process. We used the IED configuration tool to get some ICDs. We created multiple instances of this in our project, and we engineered some part of the configuration. All of this in the system integration tool. Now, what happens if we need additional parameters? There is a logical node missing, or maybe there is a data attribute missing that we know the relay is capable of, but it's not in the ICD file. Well, in that case, we need to do some changes. What we could do is we go back, go to the IED configuration tool, and get an improved or better suited ICD file. What happens then is, we need to re-instantiate it, and all the work we've done on the IED at this point is lost. We have to redo it. Depending on which tool we use, this may take quite some time, and depending on how often we have to do it, this may become quite the aggravating step during the engineering. So instead, we take the SCD and we feed the SCD file back to the IED configuration tool. And this one reads in all the IEDs present there and hopefully recognizes them as, I've produced ICD files that some of these IEDs are based on. So we load these already instantiated IEDs and we add an additional datum over here. And the system integration tool then can load this IED and replace the original one with something that has this modification that we were looking for. And then we can proceed with the new data model and add some more communication that we weren't able to do before. So the final resulting SCD then should contain these changes, and if we need to do more iterations, it will look exactly the same. So what's in the IED, it's called the Instantiated IED Description. It's basically a tiny subset of what will become the final SCD file. It contains exactly one IED. It doesn't need to be template, but rather it's the name of the IED in the project. After all, that one is unique, and when we re-import it, we need to make sure that we actually replace or update the correct device. And of course, it keeps the data type section. And it's also possible to preserve all the network settings, or rather it would be very inconvenient to just lose those. Finally, when we do have a finished SCD file, the IED configuration tool, or rather all of the tools, can use this to configure the relays themselves. So the CID file is not necessarily an SCL file. It can be a proprietary format, it can be a binary format, but quite a few vendors can also take an undigested SCD file or even load it directly to the relay. And this contains not only one IED, but rather all the publishers of communication that the IED to be configured is subscribed to. So this, in contrast to the IID file, this will contain possibly many IEDs in duplicates, but only one of them has their complete communication configured within this file. This can then be loaded into the relay themselves. Finally, there's a file that I haven't seen in the wild more than twice, I think. So I'm not sure how your experience is. This is the SED file. It's the system exchange description, and it's what happens when you want to synchronize two projects. For example, you have two substations, and they communicate with the same network control center with some switches that are down the power lines. These files are snapshots of the project, but with all the information that is not necessary for the communication to some other substation removed. And in addition, the IEDs present there may have their engineering rights restricted. So in the IED description, there is a a data field for engineering rights. And when you export an SED in your one project, you will set the engineering rights to restricted on the IEDs that you own. You give it to the other vendor or to the other team, or maybe you just hop over to a different computer or a different project and import it yourself. And in theory, the other tool that imports this file will then prevent you from changing any of the IEDs that you don't have the rights to.